So in continuing lesson 2, we're going to do part 2, which is going to cover greatest common factor. When we talk about greatest common factor, we're always referring to the largest or greatest integer that is a divisor of every integer in a set. Oftentimes, there might be multiple things that are a divisor of every integer. For instance, if you talk about the set of even numbers, 2 is a divisor of all of those numbers. Okay, so there's often different things that are divisor, but we're looking for the greatest or the largest integer that divides everything in a set, or is a factor of everything in a set. So if we look at our example, there is also 2 different ways that are very similar to what we talked about with prime factorization. And the first way is to actually use the prime factorization. So we need to use the prime factorization of 12 and 42. So if I do 12, well, 2 goes into 12 6 times, 2 goes into 6 3 times. So the prime factorization of 12 is 2 squared times 3. The prime factorization of 42, and again, I'm using the reverse division. If you want to use a factor tree, that's fine. So 2 goes into 42 21 times. 3 goes into 21 7, so it's 2 times 3 times 7. So these are both represent our 2 numbers. The first one represents 12, the second represents 42. And if we're looking for something that's a common factor of both, then it must be represented in these prime factorizations. So what we're looking for is what prime numbers are in both prime factorizations. Well, we first look at 2's. There is 1 2 in both of these. And so that means 1 2 is represented in both prime factorizations. So we know that our greatest common factor is going to have 1 2 in it. Then we look at the 3. There is 1 3 in both. So they have the 12 and 42 have a 3 in common as a factor. So our greatest common factor must have a 3 in it. The 12 doesn't include a 7, so those are the only things they have in common. So that means our greatest common factor is 6. Okay, the second method you could use is a reverse division. And so this is basically looking at the 2 numbers together using reverse division. So what we do here is we do 12 and 42. And what we're looking for when you do reverse division is any number that goes into every number inside that reverse division. It's got to go, for it to be greatest common factor, it has to go into all of them if it's going to be the greatest common factor. So we look at what number goes into both 12 and 42. Well, they're both even, so 2 has to go into both of them. Again, we're only looking for prime numbers out here. So 2 goes into both of them, so you have a 6 left over, and 2 goes into 42 21 times. Well, 2 obviously doesn't go into 21, but 3 does go into 21, and 3 does go into 6. So that leaves us with 2 and 7. So since we are down to these 2 numbers being what's called relatively prime means they have no factors in common except for 1. The only factor they have in common is 1. That means then the prime factorization is always this part of your problem, so 2 times 3. So the answer is 6. Again, that's another way to use greatest common factor. So I will, for the example 2 here, I'm going to use prime factorization first. So let's do prime factorization to find the greatest common factor of 28 and 70. So we do 28. Well, let's just do factor tree this time. So for 28, factor tree would be 4 times 7. 7's already a prime number. 2 times 2. So our prime factorization of 28, I'll write it over here, is 2 squared times 7. Look at the prime factorization of 70. To me, the easiest way to do that is 7 times 10. 7's already a prime number, so we're going to look, we got to do 10, which is 2 times 5. Now we have all prime numbers, so the prime factorization of 70 is 2 times 5 times 7. So the prime factorization of 28 is 2 squared times 7. Of 70 is 2 times 5 times 7. And so our answer is what they have in common. Well, they both have exactly 1 2. This one has 2 2's, but for greatest common factor, we want what do they have in common? And so it's going to be 2, because they've got a 2 in common, and then a 7. They both have a 7. So 2 times 7, which is 14. So the greatest common factor of 28 and 70 is 14. Okay, for this last example, and again, it's always a good idea to pause the videos and try these on your own. So we're looking for 36, 54, and 144. On a greatest common factor of those three numbers. This one you can either use prime factorization or reverse division. Let's use reverse division. A lot of times it's easier to use reverse division on a big set like this when you got more than more than two terms. So reverse division, what goes into all three of those? Well, I know 2 does, and so that's going to leave me with 18, 27, and 2 goes into 144 72 times. Well, 2 doesn't go into all three of the remaining ones because 2 doesn't go into 27, so then we move to 3. Does 3 go into all those? Well, the answer is yes. Those are all pretty common numbers. You may not know 3 goes into 72. You may have to do that on the side, but it does it 24 times. Then I look down at the next set, 6, 9, and 24. 3 goes into all three of those, 2, 3, and 8. And we know we're done because 2 and 3 are relatively prime. If any 2 of the 3 are relatively prime, then you know you're done because there's nothing that goes into all 3 of them. So the prime factor is, or the greatest common factor is going to be the numbers on the left, which is 2 times 3 times 3, which equals 18. So the greatest common factor of 36, 54, and 144 is 18.